Hello everyone, my name is Alvaro, and today we will be solving another problem from the blind Leetcode 75 problem list. Today we will be doing problem number 20, which is called valid parentheses, and this is a very common problem that you might be asked in internship interview questions. So let's get to read the problem statement and then let's get to work on the problem. Given a string S containing just the characters open parentheses, close parentheses, and then the curly and the square braces, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, or, open brackets must be closed in the correct order. Example 1, this is true because there are only regular parentheses and the closing one is followed. The opening one is followed by the closing one. This one is true as well. And this one is not true because we have an opening parentheses and then a closing square brace. So, okay, and some constraints. S consists only of this, and the length can be this long. Okay. So, as usual, if you want to work on the problem by yourself, now will be a good time to stop the video and get to it, and because I'm going to discuss now how we will be solving this problem. Okay, so we're going to use two approaches. I'm going to start using an approach that's going to use a bunch of if statements and checks to make it look so that the logic is pretty understandable. And after that, we're going to simplify that by using a mapping, which will be a little bit easier. But, let's start with the first approach that I mentioned. So the main idea here is that as we go through the string, right, whenever we encounter an opening string, meaning an opening character, which would be either this one, or this one, we would add that to a stack. So for example, we would have a stack that keeps track of everything. And whenever we encounter a closing element, then we pop an element from the stack. And remember that the stack one is last in, first out, meaning that as we put things in the stack, for example, if we suppose that we have this followed by this and followed by this, right? If we put this one first, this one second, and this one third, the first element that will be popped will be this one, okay? So the idea is whenever we encounter a closing element, so either this one, or this one, and we pop an element from the stack, if that element does not match the opening bracket, then that means that the input is wrong. And that will be the whole approach. And at the end, we just have to check that the stack is not empty, sorry, because if the stack is not empty, that means that there's extra opening characters. So let's get to work on it right now. So we will use an array list here because array lists in Python have pop methods, so they can be used as stacks in an efficient way, of course. So let's see. The first thing is that we are going to use a pointer. And then we can just keep adding stuff. So, sorry. So let's start with opening. We can define two sets here. So an opening here will be the characters that are part of opening. So this will be one. The characters that are opening brackets, braces, or whatever you want to call them. So you have that. And the closing ones will be pretty similar. Okay. And then we can just start looping through the array. So while the pointer is less than the length of s. So there are two cases. If s pointer is in opening, and then we simply append s pointer to the stack. So stack.append as pointer. The other case is that it's in closing. So if it's in closing, if the stack is empty, so if the length of the stack is 0, then we return false, because that means that we have encountered more closing parentheses than opening ones. So there's nothing to pop here. Now, if it's not empty, then we can say to compare is equal to stack.pop. So what this does is it grabs the last element in the stack, so whatever's at the end, it eliminates it and it assigns it to this variable right here. Now, we can use the if statements here. So if s pointer is equal to this and to compare is not equal to this, then we return false. Similarly, we can do this with this one right here, and this one right here, and this one right here, and this one right here. Whoop. Because this means that we have parentheses that don't match. Okay? And in the case that none of these happen, then we're completely fine, and all that we have to do is just increase the pointer by 1. And then at the end, we just have to return if the stack is empty, that means that we have found a perfectly balanced string, so that's good. And if it's not empty, we return false. So this would be, actually I'll just write it down this way, okay, it's easier to read. So if the length of the stack is not 0, we return false, else we return true. This would be the same as typing return length of stack equals 0, but I feel like this might be easier to read for some people. So if we submit this, we can see that the runtime is pretty good. Obviously, like there's some comparisons here and it's inconsistent, but we can definitely tell that, you know, it's a big O of n solution because it traverses every element in the string at least once. And also, what it does is it uses a big O of n space-time complexity because in the worst case scenario, we have a string that it's only opening brackets, and there we would just continuously be storing elements and elements in the worst case scenario. So that's why the space-time complexity of this solution is big O of n. So what we can do is we can also make the code a little bit cleaner. So let's think about it this way. We have two sets here, right? But what we can do is we can create a mapping between the opening ones and the closing ones. So for example, we can say, I don't know how I called it, but I'm going to say, we can call it a mapping. So we can create a dictionary, okay? And the dictionary, actually, wait, there you go. I like it better this way. So the dictionary will have the opening elements as the keys, and the values associated to those keys will be the corresponding closing element, right? So it'll be like this, and then we do the same one for the curly braces and the square ones. And I hope I typed this properly, because it's a little bit hard to check. There you go. I think this might be easier to read. Okay. Perfect. Now we don't need to worry about opening and closing, so we can simply say if pointer in mapping and stack append. Else if length of stack is that, to compare that stack.pop, and then we can get rid of a couple of these statements. What we can simply say is the following. we can say, okay, if s dot pointer, what we can say is, okay, to compare right now, right, will be a value, because to compare is always a closing element. So it'll be either that, or that. So what we can simply say is, okay, well, we know, sorry, to compare will be an open element in this case, my bad. And s dot pointer in this case will be a closing element. So we can simply compare we can check if mapping sub to compare, because remember, it would be a key. So if the value that we currently have is associated with the key, then we are good. So if mapping to compare is equal. So for example, if to compare is this, right? Mapping to compare will always return this. And if to compare is this, then mapping to compare will always return that. And if to compare is this, then mapping to compare will be equal to that. So if this right here is equal to the current element that we're looking at, so if it's not equal, we would return false, else we continue. And that'll be a slightly faster version because it uses less comparisons, Instead of checking one comparison, then another, and then another, it simply fetches one element and then another and compares them. So the runtime complexity is still the same. It's a big O of n, and the spacetime complexity, it's still the same, but it's a small improvement in which we can see that even if the runtime complexity of a problem doesn't change, we can always optimize it a little bit if we use less if statements, because there's less comparisons. And yeah, that'll be the end of the video. I hope you enjoyed it and found it helpful, and see you in the next one. Bye-bye.